What?
Where'd you get it?
Burger.
You
have to take the shirt off underneath.
Over the weekend.
That's what Jardo and Alex said.
No, they didn't.
Check my story.
Ethan, who are you twin with?
You're not doing buddy. You're
Why?
Can I get you guys a sort of guy.
Huh?
I'm doing it.
How are you
You're not twinning unless you do it.
I'm telling you what I mean? You know, technically you guys are twins. I mean, you are the complete opposite. Are we twins? I think we're twins.
Yeah, who you twin with?
Well,
Right? Well, if you want, me and Spencer are twinning right now. Me and Durger are twinning right now.
what is it?
Actually, you
Me and
guys.
Seth are twinning right now.
Is this girl shirt? There's like 7 of them. We bought them all.
Oh, did you?
You guys are really fucking useless. What's up, man? Taylor, I can't wait to wear my fur coat with them. Sweet, man. I don't want it. Do it harder.
I'm just gonna wear my dad. Who are you twin with?
I'm giving you my shot. He's not even. They don't even look through silence.
Oh, Reba.
What's in American?
No.
Remember that?
I think it's because of
What?
Darren.
You would have said something? I think we're off. Where's your other catch up?
Fine, you really want it. But then if you reuse it, that's not the
P.7.
I mean, sure, those would be easy. Not if you do every single year.
I missed it.
We'll let you anyway.
I missed it. I'll try to.
Huh?
You should have the 16.
I don't know, I'll say it here with the back to you.
Okay. Alright, so what we're going to look at today, we're going to just do a couple notes today, that's it. A couple notes on what we discussed yesterday, which was solving equations, right? That was our title of our section. Now, we talked about linear equations yesterday. We also discussed how to do absolute value problems and multivariable like equations, which aren't really technically multivariable, but that's what we're going to pick up with today. We're going to start with those. We might do a problem where we do a couple square roots and some of those problems. So I want to kind of give you kind of a taste of what the different types of equations are from your textbook. Okay? So if you want to take out your notes, that'd be a good thing. I'm just going to pick a couple problems from the book today, and once we're done with the select few that we have, then we'll go ahead and then I'll let you have time where you can just kind of work. But first and foremost, let's go through a basic problem here. Let's see if there's anything I really want to cover. Okay. Sorry. All right.
What's this cord hanging out of the ceiling?
It's my HDMI cord. So
And the eye still over here.
yeah, I know. So I'm gonna rewire it. I tried to do as fast as I could this morning. So and good thing there was a very good hole there, so I didn't throw one. But I had to get it because before I was using like a little 1 foot, 2 foot cable from there, and I had always moved it. So I moved it to here, but I'm either one there.
Yeah, it was really bothersome.
Anyway, so.
The lights not on today, that's reassuring.
What is it? No. So, okay. So section. We're on section P.7 today. Solving equations. Okay. Now, yesterday, when we talked about these solving equations, we talked about a process. It's called inverse operations, right? Inverse operations is kind of just an outline of how you should attempt a problem. It's not this end-all, be-all of solving equations. It's just kind of a guideline. So I talked about yesterday, like I showed you a problem where we did it like 2 different ways. Don't get too worked up on like the strategy that you have to use. Like you always have to follow one rule. Most times people's instincts on how to solve the problem are usually the correct one. So, like if you know that you want to simplify the problem first, or you want to move something over first, that's fine. You can do that as long as you're doing the correct math. So now if you're moving things across equal signs, you should do the inverse operation. That's like the overall goal. So, if there's a +3 over here, we can move it over. For some reason, it should be a -3. All right. But again, yesterday we talked about linear equations. we'll try an example of that today. We'll just do kind of one. I won't do it multiple ways. We'll just do one. Make sure that you're comfortable with it. We'll try a multivariable problem today. Just make sure that we're comfortable with the multivariables if there's more than one. I'm going to show you a completely different type of problem when we do multivariable today. Not just like the one that we did yesterday, like way different. Way different. So that's kind of our goal for that. And then the goal today, after we get through like one or two of these, we need to talk about quadratics. We need to. I mean, there's too many types of concepts of quadratics that we need to be able to solve and show you like the shortcuts and the methods you should know how to do. There's one part that would be probably brand new to you in this that you probably have not seen, so we're going to have to take our time with that. And that's something we might work on also tomorrow. Does that make sense? Okay. But that's kind of a big deal. That's our main goal for like today and tomorrow. Just definitely get quadratics so that you know how to do them. But again, our goal today is just do a few examples, make sure we're comfortable. What's due tomorrow? Homework. Okay, that's the page 79 stuff. So I'll give you some time today to work. I think we're out of here. 13 is working after something like that. So we'll go for about maybe 15 minutes, and we'll let you have some time to work on that. Yeah, the good thing is there's nothing major going on tonight for school-wise. All right. So let's start with the linear equation. I'm just going to borrow your book here. I'm just going to pick one right out of the actual text, right out of the homework section. That'll work. Give me number 16. That's a good one.
3x over 5 minus x minus 3 over 2 equals x plus 2 over 3.
Okay. All right. This is still considered, most people look at this and think it's multivariable. I realize that it looks like there's multiple variables there, but how many different types of letters do we have? One. So it is a single variable problem. It is a linear equation. If we were to simplify this, it would represent kind of a line, that type of thing. So that's what we're going to try to look at. Now, the strategy we talked about yesterday, this is the one type of problem with the linear equations, multivariable that we talked about. The easiest shortcut for this is to get rid of the fractions. You don't need to combine fractions, like adding and then, just multiply by the common denominator. So what's common denominator between 5, 2, and a 3? Not 15.
20.
30.
No,
30. Maybe 30. Yeah. The trick is just multiply them all together. That's kind of the easiest way. They're all prime numbers, so you can just multiply them together. So we're going to multiply everything by 30, right? Now, why I'm doing this is a property of equality. If you multiply by 30 on one side, you have to multiply by 30 over here. Well, when you multiply this side, and this, for some reason, people can't wrap their head around why you have to do it both. Because this is technically what you're doing. You're taking the entire side times 30, right? I'm taking that entire side times 30 because the equal sign separates them. Well, when you do that, you have to distribute 30. That's why it gets multiplied onto everything. Okay, does that make sense now? Why we do it? Okay. One of the ways I discussed yesterday, and this is the strategy that I use, I divide first, and whatever's left over, you multiply to the top. Because I know when you divide this, you'll have a bigger number that will be left up top. That's what I just know, because the bigger number is outside, not on the bottom. So 30 divided by 5. 6, take it times the top. 18x's. Because 30 divided by 5 is 6, and you take that times the top. Because technically what I'm doing is I'm putting this over 1, and I'm simplifying diagonally before I multiply straight across. That's what I'm doing. That's why it turns out to be 18. Okay, any questions with that? Okay, good. Next, 30 divided by 2. 15, and that's what you're going to take times the top. And notice I'm writing this. I'm not distributing it right away. Taking 15 times the top. Because technically over here, what I did is I actually took 6 times the 3x. That's what I'm actually doing, right? Over here, 30 divided by 3. 10, and you're taking that times the top. And it doesn't matter if you put the 10 in the back or the 10 in the front. It's the same problem. Okay. Questions, comments, concerns? Okay, good. All right, let's move on here. Let's actually multiply. We already did this one earlier. I just erased it. So that was 18x. Distributing this, what do we get? 18x plus 45. Plus 45, okay. And then over here, 10x plus 20. double check my math, make sure we're right. Negative, positive sign's a big deal. Make sure we're getting those. Now we can combine like terms, and we can move things around. So if I add these x's together, I have what, 3 x's. The other side is 10x, 20. Okay. So far so good. Okay. Let's move things around here. So let's what I'll do is maybe I'll move the 10 over here, move the 45 over, or I can move the 3 and the 20 over. Which way do you want to go?
Minus 20.
Minus 20 over.
Yeah.
So we'll move all the x's outside. So I'll move the 3x over, making that 10x minus 3x, right? And I'll move the 20 to this side, making it also subtracted off, right? This turns out to be 25. This turns out to be 7x. And then you divide by 7. And I know it turns out to be a weird fraction. That's fine. Your answer in this particular problem turns out to be 25 over 7. Which 7 goes into that, what, 3 times with 4 left over? 3 times 7 is 21, yeah. 21 is different. 4. So 3 and 4 is 7. So you will get fractions for answers. This was literally right out of the book from 16. Yeah, so you're going to get fractions. You just got to be comfortable with that. I don't mind if you leave it to improper versus go to mixed number. I don't mind. So it's whatever you prefer. Because maybe you're that person who just wants to leave it with sometimes. But just make sure that if you're checking the back, you're not like freaking out that you have a different answer in the back. They may have just put it in mixed number or simplified the fraction a little bit. Okay, any questions with that? Okay, good. Now what we're going to do. I want to talk about multivariable problems. I don't consider this multivariable. It's got 1x in it. It's still linear, right? I want something that has multiple different letters in it. And that's the main difference that we're going to pull here. So, let's see if they got some. Give me one of these. I don't care which one you tell me. Okay? So, avoid these. Yeah, avoid it. Anyone that you want.
Okay. S equals C over 1 minus R for R.
Fold. I don't know.
4, I mean.
Like that. Okay. Okay. And that is an S, not a 5 or. All right. What you're looking at here. Would you agree this has multiple different letters in it? Okay. What they're going to do is they give you the problem, and then they ask you to solve this for one letter in that problem. A single letter. So what letter are we going for? R. So all they want you to do is, this is a big fancy way of saying, rearrange the problem. That's all they want you to do. You're not really solving. You're just rearranging things. So what I would do is I want to make sure that I can get R to one side by itself. Does that make sense? So I'm going to move R. So right now, do we agree that R is on the bottom of this fraction? Okay. So we're going to try to get this R so it's not on the bottom. I like to have it by itself. So what I'm going to do is I'm going to multiply this thing across. I'm going to let it do that. That's an inverse operation. This side it's dividing, and I can multiply it to the other side. Because technically what I'm doing is I'm multiplying both sides by 1 minus R. Right? Does that make sense, like what I'm doing? These would eventually cancel out. That's what's just going to happen. All right, so what I'm left with on this side is a C. On the other side, I have an S times a 1 minus R. Make sense, what I have so far? Okay, what I'm going to do is I'll distribute the X, just like before. Just, it's simple math, just like what we're used to doing. So if I distribute the S, what do I have?
S1 minus SR.
S minus SR, okay. So it's a 1S minus an SR, and you don't need to, I just put it in there so you know it. Okay, we get it so far. Now, all I need to do now is solve for R. Because R is kind of by itself now. There's no weird fractions going on, there's nothing. I can get R by itself. So what I'm going to do first, let's move this 1S across. How do I move it across? I heard it. Subtract it, yeah. So this is what we're at so far. I'm going to subtract that 1S across. And if you just want to write S, that's fine. Okay, we good so far with like subtracting that across the equal sign? Because they subtracted it from the slice sign. That's what I did. And what's the last step? How do I get r by itself? Divide. Yeah, divide by negative s. Divide by negative s. And these would cancel, leaving me with r equals c minus s over a negative s. Now sometimes they won't put the negative sign on the bottom. Like this is the answer. Like that's what I want. Sometimes the book won't leave the negative sign down there. What they'll do is they'll just put the negative sign out front of this. Sometimes they'll distribute the negative sign to the top. So it could be like this. Because if you distribute the negative sign to the top, that would be a negative c and a positive s, so they'll rearrange it. I don't know which one. To me personally, if you get to here, just leave it like that. I don't want you to be confused if you look at the back of the book and they have this sitting there, and you're wondering how they did it. They distribute the negative sign and move it out front and distribute it to the top. So it doesn't matter where you put the negative sign, top or bottom. Okay, we good with that. Like that's just rearranging. So you have to follow the rules, inverse operation. That's the idea. That to me, that's a multivariable function. Different letters. Okay, we're good. All right. And we're gonna do one quadratic here.
And we don't want to take an S out from that fraction because it's in, like the S, you don't want to take an S out top and bottom.
You could. I mean, you could technically do it. I mean, you could divide the s's out, like in that final answer. You know how the s over s minus c would be negative c. You could go 1 minus c over s, because you could divide each by s separately. Okay. Quadratic. Really, any of those, any of these, really? I mean, you can just kind of pick whatever one you like. You know, we'll make them work.
X squared.
X squared.
Yep.
Okay.
Minus 13x plus 36 equals.
Okay. All right. First thing we would attempt to do, if you want to solve this thing, right? If it's a quadratic, there's two different ways to do this problem. One way to do this problem, you bring everything over to this side, like I'm doing here, and you get 0 on this other side. And you just make sure it's in descending order. I always, when I do this in descending order, I just make sure that there's no number in front of the x squared. That's what I just make sure. So I like to have a 1 there. It's not a big deal. And if there's a number there, we can deal with it. But usually I don't want a negative sign here. So I try to make sure that it's positive and it just goes its way down. So one way to do this problem, you could try to factor it. That is one strategy you can do to find answers for this thing. So if you're really good at factoring, you like it, you do this. Because it would be what? Minus minus, x and x, and what are numbers that would multiply to give you 36 but would add in the middle to give you the negative 13, 4 and 9. 4 and 9 multiply to give you 36, they'll make 13 in the middle. So what they want you to do is solve this thing. So one of these parentheses needs to be 0, right? If this parentheses is 0, and you take it times the other parentheses, you get 0. So there's two numbers that could solve this thing. What are they?
4 and 9.
Positive 4 or positive 9. There's two potential answers that it could be. I don't know which one it is. That's why I use the word or. Make sense? That's one strategy, factoring. Now let's say you couldn't factor it. Let's say that you're not good at it and you're struggling. Like, God, I don't know how to factor it. You don't need to. You can do the quadratic equation. So that is the other strategy. So this is A, this is B, and this is C. And A is a 1, thankfully. Okay? And the formula is x equals, because you're solving for x, negative b plus or minus square root b squared minus 4 and a and c all over 2a. All right, and I'm betting on all of you have that little sum stuck in there, correct? Yeah.
Now I do.
Yeah. I hate it. I don't like it. So, all right, so. Okay, so what they do is it's the same problem as we did over here. You're just taking each of these numbers, plugging it in, and it actually solves out your answers. In fact, your answers, guess what they're going to be? Same thing. Those two. Same thing. That's what's going to happen. So it doesn't matter. This is just a different strategy for doing quadratics. I always like to give you multiple options in case it's non-factorable. Like, let's say you can't factor it. Let's say the numbers don't work out to make the middle. So now you have to do this. factor it other than just doing the quadratic. So negative b, so it's 13, that's a positive 13 now because it's negative 13, plus or minus square root 13 squared is 169, positive because it's squared, minus 4 times a, which is 4, times 36. 36 times 4, what is that, a 9, carry the 249? I have no idea. 36 times 4. 4 carry 244, not 149, 144. Alright, so it's 144, and then the 2 times a, so that just be a 2. Okay, good so far? We simplify that, the radical, so 169 minus 144 is 25. So we have 13 plus or minus square root of 25, which is actually a really, really nice number.
I don't understand you do it that way.
If you can't factor it. If the problem's non-factorable, like right here, like if you can't break it up into parentheses because the numbers don't work out to make the middle, you have to do it by that way. It's the only way that you can get answers correct. Because they could be decimals. This would only give you answers if they're nice whole numbers. This will give you it no matter what, if they're crazy decimals, irrational numbers, imaginary numbers maybe. Yeah, that's a good question. So, all right, what's the square root of 25? 5. So far, what we're at is we're at this. We're at 13 plus or minus 5 all over 2. Well, now you can just do the math. 13 plus 5 is 18 divided by 2 is 9. Or 13 minus 5, which is what? Is that 8 divided by 2? And that's 4. So it gives you both answers, no matter what. Now, obviously, sometimes when this works out to be crazy decimals, this square root won't work out so nice and pretty. It'll be like like a 12 square root of 12. Well, you can't break that down. So it'll be decimal. Okay. Yeah, so you continue to solve it using quadratic. So, or you break down this first. That's it.
So, let's say the square root is 12, that would just be into that?
So if that's a 12, I would probably go 13 plus or minus 2 root 3 over 2.
Okay.
So I would just break up the 12 as far as it goes. Okay. Do you feel comfortable with quadratics as of this moment? Tomorrow you will not be. I will guarantee it. I will give you problems that you will not like to not do it. So, okay. So, homework today, make sure you're working on that page 79. That's due tomorrow. So you have the rest of the class, which is about 15 minutes. But again, you've got to search for quadratics today.
Huh? Wait, I think it was about like 9:30. Last night, 11 o'clock I was up there. I love my sleep. I go to like 9:30 every night.
I got it. I'm trying to figure out what to do with this ice. Ooh, T.O. Yeah. Is that like a workout band? Yes, it's like that. Oh my god. Wait,